This one is a project at the Selangor, Sepang. The bridge is to cross the Sungai Sepang Kecil, but the name does not justify the size of the bridge, the size of the river, because we have another river at the other side of town, which is Sungai Sepang Besar. So Sungai Sepang Besar is narrower compared to this Sungai Sepang Kecil. So we have a 3 span of bridge, a 20, 30, 20. So all total length of bridge is 70 meter. So you can see here, this is a dowel bar. So dowel bar here, where you're gonna cast the approaching slab. They call it approaching slab. So you have approaching slab here. This is your deck, bridge deck, being like a hook to your plinth of the plinth of the abutment. So this is steel, as you can see here, a projection, or we call it rib. We have a projection of steel to increase the friction between steel, reinforcing steel and concrete. So this is bar is for the wing wall of the bridge. So wing wall, and then to the parapet of the bridge. So basically serves as the guardrail to the bridge. So this is an example of plate being rolled into pipe tubing. So in this construction, they specify that the from the top to the depth of 12 meter, we need to embed casing to prevent erosion, to also assist in the drilling of bore pile, the boring of bore pile. So this is an example of steel material. As you can see here, a close inspection is the plate's not that thick. It's a 12 mm plate, which is cheaper. 12 mm plate, cheaper and easy to be rolled, and also cost effective to be used as a permanent casing. This is a permanent casing, so the casing being driven into the soil before the drilling process began. So you can see here this crawler crane. We call it crawler crane because basically the crane is crawling at slow rate, so we call it crawler crane. Have track here, but even though it has tracks to move on soft grounds, but also still need to provide plates. As you can see here, there's a plate, there's plates here. This is a thicker plate. I think it's a 24 mm, 25 mm plates, which can sustain heavier loads to carry this machine. This is an RCD machine. It's a reverse drilling machine. Rather than we drill the machine, we drill the hole from top to the bottom, but in RCD we suck the soil from the ground up to the surface to produce a hole. So they call it reverse. So the pipe tubing is being lowered down, being extended, connected at each depth. So as we increase the depth of drilling, we add more pipe tubing here. So these are all steel materials. As you can see, steel materials is strong, ductile, and lightweight. It's lighter and easy to be handled compared if it is made from concrete. If this pipe is made from concrete, so it's a heavier load. So imagine if this universal beam is made of concrete, so a lot of support need to be provided, because as you can see here, the water down here is a clay. The soil beneath the water is clay. It's a soft soil. So to sustain a heavier load will be not realistic. So you have much more settlement. You need to provide stronger supports. So you need to provide much more foundation here, or you can also provide a deeper foundation, but it will be costly. So this is example pipe tubing. So basically once we finish at this stage, we finish a bridge, half of a bridge. We do half longitudinally. So we have completed the first half, so the traffic can be diverted to this new bridge while we drill a foundation at the old bridge. So you can see we have hacked the bridge here. We can see close up here. This is the old beam, the beam of old bridge. So they use actually the beam is closely placed together, because it's an old design. It's being placed close together, and you have so many. We have a shorter span as opposed to before. As opposed to the new one, we have a post tension bridge, but the old one they just reinforced concrete bridge. It's not post tension, so it's an old bridge. It requires a shorter span. But just want to show here, it's a plate, an I-beam, it's all the products. And also you have a truss here. As you can see, it's a T section we use as a truss to carry this. We have a telecommunication cable and here, and also TNB cable if I'm not mistaken, that later being HDD, horizontal direct drilling, from one end to the other end. So the cable goes from this pole underground, crossing this river beneath the soil. So this in old design being converted into a new system. We have a HDD, we have post tension. So this extended rebar is the extended from the deck slab. So will be tied together with the new bridge. So you can see here the new bridge having a higher finish road level as compared to the previous one. This is based on the 100 years of flooding. So the designer want to prevent any obstruction of water flows due to position of a pier head. So in case of a water level rises, it won't be obstructed by the pile head.